If you've ever walked through a wartime bunker, an old aircraft hangar, or a forgotten supply depot and noticed how the wood still looks stubbornly intact, you've already brushed against one of the quietest material revolutions of the Second World War. These structures were never meant to be beautiful. They were meant to survive blast shock, flying debris, weather, insects and time. And somehow they did. During a war where steel was rationed and concrete was slow, engineers turned to wood and made it tougher than anyone thought possible. They did it not with magic, but with chemistry borrowed from shipyards, oil refineries and early plastics labs. The result was a paint additive so effective that it fundamentally changed how wood behaved under stress. This wasn't about making timber invincible. It was about buying seconds, absorbing energy, and keeping structures standing when everything else failed. That forgotten solution still matters today. Why wartime engineers needed wood to behave like armour? By the early 1940s, every major power faced the same problem. Steel was prioritised for tanks, ships and aircraft. Concrete required time and transport that frontline engineers didn't have. The solution came from naval coatings and early industrial resins that could be brushed on like paint, yet cure into something far tougher. The additive that quietly changed wartime construction. The secret wasn't a single substance, but a class of additives built around bitumen, rubber latex, and phenolic resins. Bitumen, derived from petroleum, had already been used to waterproof ships and rail cars. Rubber latex, both natural and synthetic, was being mass-produced for tyres and seals. Phenolic resins, the same family that gave rise to bakelite, were among the first true plastics. When combined into heavy-duty paints, these materials created coatings that didn't just seal wood, but bonded with it. Once cured, the coating formed a flexible, energy-absorbing skin. Instead of cracking or splintering when struck by debris or shock waves, the wood fibres were held together. Tests showed reduced spalling, fewer lethal fragments, and far greater resistance to abrasion and penetration from shrapnel and small debris. Calling it bulletproof was wartime shorthand. The real achievement was controlled failure instead of catastrophic collapse. Now, let's look at how this coating actually worked on a material level. Rubber introduced elasticity, allowing the surface to flex instead of shatter. Phenolic resins hardened the outer layers, increasing compressive strength. Together they turned wood from a brittle structural material into a laminated composite. This is why, many wartime wooden structures show these sort of rounded impact marks instead of, explosive splintering. The coating actually absorbed energy and kind of redistributed it across a wider area. That same principle, believe it or not, is still used today in modern spall liners and impact-resistant composites, just with more refined chemistry. So, where was this technology actually used during the war? Well, this wasn't just some bit of experimental trivia. Variations of these coatings were applied in aircraft hangars, ammunition crates, field barracks, ship interiors, and even temporary blast walls. Naval forces, for example, use similar formulas to line compartments and reduce fragment spray. Some airfields, on the other hand, applied them to wooden revetments designed to shield aircraft from strafing runs. The goal was always the same, really. Reduce casualties, reduce structural failure, and extend service life under brutal conditions. You know, many of these structures were never meant to last beyond the war. That they still exist today is, well, the unintended proof of just how effective those coatings really were. There's still a lot modern builders and survivalists can learn from all this. The real lesson here isn't actually about stopping bullets. It's about, understanding energy, moisture, and how different materials behave. Modern sealants often focus on surface appearance and water resistance, but honestly, they can harden wood into something a bit brittle. Even today, marine-grade bituminous paints and rubberized coatings, well, they outperform many of the consumer wood sealants when it comes to sheer durability. The key, really, is using them in situations where abrasion, impact and moisture are the real enemies. So, why did this knowledge quietly fade after the war? Well, after World War II, plastics and synthetic building materials absolutely flooded civilian markets. Pressure-treated lumber quickly became the default choice. You see, speed and cost replaced longevity as the main priorities. Those specialized coatings from wartime days were messy, dark, and, well, industrial. They just didn't fit the neat, bright suburban aesthetics folks wanted. Over time, that know-how stuck around only in naval yards and heavy industry, while civilian construction simply forgot it ever existed. And yet the surviving evidence never really went away. Old depots still stand, Crates pulled from storage still hold together. The chemistry did its job, and honestly never asked for any recognition. So why does this forgotten solution still matter today? As climate stress increases and material costs rise, rediscovering durability really does matter. World War II engineers solve problems under pressure. Problems that modern builders often sidestep with, well, endless replacement cycles. Their paint additive didn't make wood immortal, but it did make it resilient. And that difference is everything. If you're fascinated by forgotten wartime engineering, lost material science, and the practical lessons history still offers, this channel exists for you. Subscribe for more deep dives into overlooked technologies that shaped survival itself. And, share this episode with anyone who still believes the past has nothing left to teach us.